My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 423. In this lecture, we will try to understand XGBoost. So, we can get a gradient boosting classifier very easily from scikit-learn. There is very nice gradient boosting classifier that is implemented. This is very similar to random forest except for couple of important things. The very first important thing is your learning rate. Your learning rate default value is 0.1. Of course, this is nothing but new in our formulation that we saw. The other very important thing that you need to remember is max underscore depth, and the default value is 3. This is also hyperparameter actually. Remember, the depth of each learner is also hyperparameter. The number of estimators, this is equal to, what is your number of estimators here? Number of estimators is equal to 100. This is capital M. All the three of them, what are three of them? Learning rate, number of estimators, and max underscore depth are hyperparameters. In the previous lecture, mostly focused on nu and m. The other parameters like max underscore depth, you can also think of as hyperparameter. As we know, in GB means gradient boosting. In general, in any boosting algorithm, if you are using decision trees, we want the decision trees to be shallow, isn't it? So remember, for random forest, the max depth is equal to none. That is one of the important thing. There is also something called subsample. Let's see what subsample does. Subsample basically says to build each of your base learners, we want to use total data or not. What subsample does? Default value is 1, which means use the whole data, entire data. But if you use the entire data, but if you are okay, you can actually train your data on a fraction of data. This is equivalent to row sampling, isn't it? What it is? It is equivalent to row sampling in random forest, because each of the base learners, if I say subsample equal to 0.5, then in each of my base learners, hm of x, it will not use my total data, it only use my 0.5 means what? My part of the data. This is equivalent to row sampling. Row sampling concept, that row sampling concept, that's an important parameter that I wanted to bring up to your notice, except that more or less same. Losses, everything very simple. Gradient boosting is very general purpose boosting here. As far as loss is concerned, you will see value called, just see there are different possible values for losses. Log loss, just check deviance. You have something like, what is this? You have something like deviance. Just see deviance here. When you use a value like deviance here, what it means? It is equivalent to logistic regression. Instead of deviance, if I write exponential, this is also equivalent to another boosting called adaptive boost algorithm. We will see what is adaptive boosting in my future classes. We will learn Jesse, we will learn geometric intuition of adaptive boosting in my future classes. But all of that can be done in a single code, because single code, especially if I have classification like setting, you can just say your loss is log loss. Very just see, if you say loss can be log loss, very simple idea, very straightforward. But my problem with scikit-learn's implementation is I have tried scikit-learn implementation in production environment for small data sets. Unfortunately, GBDT or gradient boosting classifier and regressor in scikit-learn, these are very slow. That is the basic problem. Actually, here just see here we have one note here, depreciated. Which one? From version 1.1. The loss deviance was depreciated from version 1.1 and will be removed in version 1.3. Use loss equal to log loss, which is equivalent, isn't it? GBDT or gradient boosting classifier and regressor in scikit-learn, these are very slow. These are not best implementations of gradient boosting. For the best implementations, that are open source available for gradient boost, my favorite program has always been something called XGBoost. That's important. XGBoost is actually a research project, I think, at University of Washington, where PhD student along with his faculty have developed a terrific. It is one of the best GBDT implementations I have ever come across. I would call it is the best from the single box perspective. From regular implementation, it's very super well optimized. Now what XGBoost does is, if you remember, the regular GBDT has all of your pseudo residuals plus additive stuff with some gradient using pseudo residual. In scikit-learn implementation, it is actually GBDT. In scikit-learn implementation, it is actually GBDT plus row sampling plus row sampling. I can say XGBoost goes one step further. It says we will have all of this. What is this? All things of GBDT is XGBoost is GBDT plus row sampling plus column sampling. When you have row sampling and column sampling, remember these two ideas are coming from your random forest and bagging like concepts. XGBoost tries to come up with, XGBoost is not a specific algorithm. XGBoost is not a specific algorithm. It is an implementation. XGBoost is an implementation of GBDT, but in this implementation, they took some liberty and said, can we somehow mix the best of GBDT and random forest? Because these are very powerful, super world-class models. So they said in addition to the regular GBDT that we learn, add row sampling and column sampling. When you add row sampling and column sampling, I am also having the benefits of random forest. I request you to go through this lecture. If you have any difficulty, please keep a comment. I will continue my discussion on XGBoost in my next lecture also. That is in lecture number 424. Thank you very much.